Welcome to this new series of Binary Beast, in which we'll be talking about Pytorch and what is actually Pytorch and how is it used. So, um, I have prepared a few topics in which we shall go on. Like in this video, what we'll be talking about is linear regression using Pytorch. I know it sounds so simple and so straightforward, but trust me, it is, but it's not so common. Okay, at least it was not for me. By the way, that when we hear the term linear regression, it's the first algorithm that we learn while we are learning machine learning everywhere. But uh, even when I was learning, it was just like, from sklearn.model selection, import linear regression, and then I can, just feed in the x value and the y value, and I get my result. And I feel like I have accomplished something. Okay, so it's not like that. We should all know that what is the working, like how linear regression is able to find the inputs, okay, and how it's able to map it accordingly. So in this video, we'll be learning each and every one of the minute details. Okay, so and we will be using PyTorch. So let's get started. So here we go. Okay. Okay, I hope my screen is visible. Okay. So here we in like I'm not taking any CSV file. I'll be generating the input set. It's not very vast data. It's just a beginner course. So I think that a few entries would be more than sufficient. So here we go. So I'm by the way, I'm using Google Colab. It's an online Jupyter notebook where we do not have to worry of importing various libraries. It's just that you can import it and you are good to go. There are many libraries which are installed in this, and it runs on cloud. That's on the therefore you don't have to worry about using any of your GPUs because deep learning and specifically PyTorch is used for when there is more of image data and not a tabular data. But here we will be covering both the aspects. So let's get started. So I'll be explaining each and every concept as we go on. So I'm just importing two libraries which I'll need. I'll need NumPy and I'll need Torch. Okay, there you go. And for all those who don't know what linear regression is, you know, I'll just give you a brief summary of what linear regression is. Okay, so here we go. So let's say that you have on the y-axis you have the weights of students, and on the x-axis you have the height. So as they say that that if the height of student increases, the weight also increases. So you have to keep in mind that like you have to find an appropriate similarity between the weight and the height of student, and then there is a linear relationship. Okay, so this is an example of a linear regression. Now, just like this, there is like a multiple linear regression where here, if we have given height and we need to predict weight, but let's say that if we are given height, we are given gender, we are given age, and then we have to predict weight. So, as the inputs get increasing, our accuracy also get increased. So, yeah, this is what linear regression is. Now we will be moving forward with our question. So let's say that we have three parameters. So here we go. We have three parameters. So we have temperature, we have rainfall, and we have humidity. So here are the inputs. By the way, I have taken reference of this from FreeCodeCamp. So they have also taught this of getting started with TensorFlow, and I have taken reference from that tutorial as well. So a huge shout out to FreeCodeCamp for providing such a wonderful source of information. So now what this is. So here we have three, like it's a matrix. It's a three cross. I don't know. It's a three cross. Like we have n cross three because there are multiple rows and there are three columns. So we have temperature, we have rainfall, and which we have humidity. So we have three parameters, and NP stands for NumPy. So this is a matrix. Here we have specifically written D type because now they are integer, but it can be float. That's the only reason. And similarly, we have the inputs. So what about outputs? So here are the outputs as well. So we have here we have one more matrix, but this time it's about two columns. This stands for 56, that stands for apples, and 70 means oranges. So similarly this. So 56 are apples, 81 apples, 139 apples, 22 apples, 103 apples. Similarly, these are oranges. Now, what does this stand for? So this stands for that, when temperature is 73, rainfall is 67, and humidity is 43, we have 56 apples and 70 oranges. Similarly, when we have 91, when there is 91, I don't know the units, but we have 91 temperature, we have 88 rainfall, we have 64 humidity. Then there are 81 apples, and then we have 101 oranges. Similarly, we have many other entries. So we are given, let's say we have this data set. Now, what we want is when I give a particular number, let's say I have 50, 60, 70. Okay, so how many number of apples and how many number of oranges will be formed? So I want that. So how do you calculate that? So we'll be teaching you that. So initially, we will be focusing on, because the equation will be something like this. I'm taking the case of apples. Okay, let's say I'm taking consider apples. So I hope that the size is. I'll just try to increase my fonts, if that's allowed, or in just a minute. Yeah, I can just zoom in that. Just a minute. Yeah, I hope now it's completely visible. I have increased the fonts. Okay, so number of apples stands for, we have three parameters with us, right? We have temperature, we have rainfall, and we have humidity. But it's not that simple, because we have multiple things over here. Weight 1 into this. Similarly, weight 2 into this. Similarly, weight 3 into this. Plus, there will be a constant. So this is the mathematical formula of multiple linear regression, where this condition will be same for oranges as well. So if you want an equation for oranges, this will be same. That when number of apples is equal to temperature plus rainfall plus constant, that's true. But not just summation of all this. We have weight 1 into temperature plus weight 2 into rainfall plus weight 3 into humidity plus constant. So our task will be to find the value of these weights. I know that we have pre-trained algorithm which can do this task for us, but we really want to know that how the weights are calculated. Our procedure will be, we will start from completely random integers. Okay, this weight 1 might be that anything. Weight 1 might be anything. Weight 2 might be anything. And weight 3 might be anything. It can be anything. It does not matter. Oh, sorry, I forgot 0. 0.1, or it can be 0.15, or it can be, let's say, 0 point something. It can be more than one also. Okay, it's not a concern for us. So it can be anything. So let's say that I'm telling like very frequently, but I don't know why it's happening. I'm sleepy, that's why maybe. So yeah, that we have weights. So we will start from taking weights completely as random integers, and then we will find out a technique in which we can go in the right direction and find the right value of these weights. There will be a right value. Definitely there will be a right value of weights, but we will see how we can find that. Okay, so let's get started. Okay, so initially, as I told, we will take the value of weights in a very random manner. But before that, we need to convert this NumPy arrays to tensor. Now, what is a tensor? Tensor is basically, it can be anything. It can be numbers, it can be vector, it can be array, it can be matrix, anything. But we have to convert this to tensor so that we can use the various operation Torch has to offer us. So torch dot from NumPy inputs torch dot from NumPy targets puts, and this will be the similar entries that we have entered above. Just a minute. It's targets. Sorry for this. I think I'm missing something. Okay, just a minute. Its inputs is equal to torch dot from what's the error? Okay, just a minute. Expected np.nd array got tensor. Okay, just I think I have messed up somewhere above. There you go. I messed up actually in the above place where I had not written the NP array. That's why. Okay, so here we have converted the NumPy to TensorFlow. So there you go, like to tensors. Okay, so it's the same, but the formatting has been changed to tensor now. We can perform the operation that tensor has to offer us, just like to do the differentiation, to do the derivatives, all that stuff we can do now. I'll explain you why we need this, but we will need this. That's for sure. Okay, we have converted this. Now we can start on with our main workflow. So what was our main workflow? As I had told you that we need to first find the random weights. Okay, it did not be the exact weights, but let's say if you only forget all this, forget this 91, 83, forget all this. Okay, just focus on this main reason that we have 73, we have 67, and we have 43. Okay, and and here we have 56, we have 70. So 73, 67, and 43 indicates this can be temperature, this can be rainfall, this can be humidity, and 56 and 70 indicates that 56 can be apples and 70 can be oranges. So here we need to find the value of three weights, so that if we multiply this whole equation, then we can get very close to 56 or close to 70. Obviously the value will be different of in the weights. Some will be different from the value of weights will be different for apples, and the value of weights might be different for oranges. Initially what we will be doing is that we will take the random value of weights. So how to do that? In torch we have a function for weights as well. Weights is equal to torch dot random. Now, like what will be the dimensions? Okay, so that's also one of the concern. We will take the 2 column and 3 rows. I'll explain you why. Just a minute. V stands for the constants. Okay. Now why have why I have chosen 2 column and 3 row, and here also why I have chosen 2 columns? There is a reason. Okay, I just told the equation that my number of apples will be weights into input plus constant. Now you might ask that you never wrote this. What you wrote was, I think I have it or I deleted. I deleted. Okay, not a problem. Number of apples. You wrote something like this, where it was weight 1 into temp. Temp stand for temperature. Weight 2 into rainfall, plus weight 3 into let's say that you wrote humidity. Okay, but if you know the spelling is wrong, but please bear with me. Okay, there you go. Okay, but somewhat it's similar, because here all the weights will be nothing but our matrices that we are writing here, and temperature, rain, and humidity will be none other than our inputs. So this is how our equation will form. But right, if you have studied, if you are a high school student, then you know that if you want to multiply metrics, let's say I want to multiply row in like one matrix who has R rows and C columns. If you want to multiply it with M2 that also has R rows and C columns, then you should know that this should match. Okay, then only we can form the matrix in such a way that M3 will be R comma R. Okay? Just like I'll take an example that if we have 3 and 2, then it should be 2 and 3, so that we can get 3 3. I'll explain in much more detail. Just give me a few time. Just give me like a few minutes. So let's say our number of apples or number of output is nothing but this is our number of output. Okay. Now, that this can be 1, 2. Okay, there are 2 columns, and how many rows are there? We have 1, 2, 3, 4, and 5. Okay, so we have output. We have 5 rows and 2 columns. And what are the weights? Okay, we have to find the weight. Let's say I'm writing. Now we want to know, right, how this 2, 3 came. That's why I'm not writing this. Now, what's the dimension of our inputs? So inputs are of dimension 3. There are 3 columns, and there are 1, 2, 3, 4, and 5. There are, there are 5, and here we have 3. Constant also we don't know. We have written 2. We have written 2 columns, but we don't know. We have written 2 columns, but we don't know. Okay, so I'm writing. Now, if we want to get this phi 2, how do we do that? We have to make this in such a manner such that the dimensions matches this. Now, how do we do that? So this, like, these are the columns and these are the rows. Okay. Just a minute, I'll showcase that also. Okay, here we have that if this is our inputs that we have with us, this 73, 67, and 43, like these are the inputs that we have with us. And what can be, these are the weights, the dimension that we have chosen till now. So here what we wrote 2 and 3, so this stands for, it's the transpose. Okay, so transpose means there are 2 columns and there are 3 rows. Similarly, there are 3 rows. Here there are 3 rows and there are 2 columns. Plus you have 2 columns. You have 2 columns. There you go. You have 2 columns and you have n rows. If this is the equation that we follow, then we get the answer of what we want. That's just a minute. I'll show you that also. If you write this equation, we will get the answer as just a minute. I'll showcase you once we move forward. I'll show you just a minute. I'll show that also. Let's say if you run this, okay, and if we create a model for our purpose, this is the input, and we are getting a return. What's the input we are getting? X stands for, basically X stands for our matrix. So at the rate, that stands for, if you want to multiply any matrix, we can use this at the rate. W, that stands for our weight, and T, that stands for, if you want to multiply it with the transpose of matrix, we can use that. Plus we have the B. Now B stands for our constant. So there you go. So in this equation, what we are doing is that, as I just told here, that X will be given by the user. We are not familiar with this. Okay, I'm just trying to erase this. Okay, there you go. Fine. So X will be given by user. I know it's like pretty confusing, but please bear with me. You will get this. You'll definitely get this, but just bear with me. X will be given by user. It's our job to specifically set the dimensions of weight and constant in such a manner such that we get the answer in this manner. That is, 2 columns and multiple rows. Okay, so the only dimension that set is if we get input in the format of consider 1 cross 3. That means 1 row and 3 column. Then our multiply matrix should be basically that, which should contain 3 rows and how many outputs you want. So we want 2 outputs, right? So we want 2. Why? Because 73 will multiply with W11, 67 will multiply with W12, and 43 will multiply by W13. This will give the value of apples. Now we want for oranges as well. So 73 will multiply with W2 plus 67 will multiply with W22 and 43 will multiply with W23 to give us B2. So that's how it's rolling. The maths can be pretty confusing, trust me, but this is the only way where I can help you understand this. So if you want to see in real time how it will look, so it's that, Fred models inputs. Okay. Now what this will give? Just a minute. Sorry for this. It's not weight, it's weights. Okay, what we are getting. To just showcase you that, here we go. These are our prediction and this is what answer is. Okay. So let's say if our answer was 56 apple, we have got 213 apples. If we have answer is 70 apple, we have got 85 apple. This is just by coincidence that this is matching so much. Otherwise, I have seen the cases where it was in minus, that you might have got minus 85 apples. And this is, valid as well, because because the weights were completely random for now, at least. In the further videos, we will try to optimize this using gradient descent, and that's why we have written require grade. Okay, so let's start out how to optimize this, because this can change. Okay, remember this 213. Now if I again roll this, it changes to minus, and it can be because it's completely random numbers. We are not doing anything. It's our job to optimize this, and that's where linear regression gradient descent function comes in the picture. Now how to do that? Okay, so the thing is, I have just showcased you. Okay, so let's just think of it this as if our answer is this. Okay, if our answer is this at this point and we got this, what's the error? The error is, let's say this is at x1 y1 and this is at x2 y2. So the answer is root of x1 minus x2 whole square plus y1 minus y2 whole square. This will be the error, and this is called as loss function or the minimum square error. Now loss function is somewhat different, but consider this as minimum square error. I'll explain you what is loss function using minimum square error. So keep in mind that. So I'll just define minimum square error. For minimum square error, we need two things. Okay, we need the predicted coordinates and we need the exact coordinates. So we need T1 and we need T2. Difference can be T1 minus T2. It does not matter if you do T1 minus T2 or T2 minus T1. They both are the same. Why? Because we are squaring that. Torch dot sum. I'm explaining, okay, how we are doing this. Difference by. Okay. Now I'll explain you how and what we are doing. Okay. I'm just compiling this function. Consider this two matrices that we have. Okay. So now if we are considering this as T1 and if we are considering this as T2. Okay. Let's say I'm passing these two metrics in the minimum square error function. So difference will be T1 minus T2. That means minus 192 minus 56. I'm not so good at mental maths, but I think it's minus 210 or something. It might be close. It might be, yeah, I don't know. I really don't know. But let's consider it's minus 210. Okay. So what it will do is similar to when I'm do subtraction of this two, it will do subtraction of all this. Okay, all this 257, 81, 69, 101, minus 299, minus 119, minus 130, minus 133, minus 181, minus 22, minus 10, minus 37, minus 255, minus 103, minus 88, minus 119. Whatever the values are, I'll do the summation. Okay, before summation, I need to do one more thing. I need to square them up. So just a minute. Let's say that we have this. Okay, so here if my matrix is 2 3 and 4 5, okay, let's say we have this consider this only one matrix. Okay, I'm not so good in this, but and here I'm taking 6 7, and here I have 8 9. Okay, so let's consider this as T1 and this as T2. Okay, so how will our minimum square error or MSE work? It will be 2 minus 6, that's minus 4 whole square, that's 16, therefore 16. Then 3 minus 7, which is minus 4 whole square, again 16. 4 minus, okay, 4 minus 8, again 16. Sorry for this example, it's okay, but just take 16 and this is all 16 and all that. Okay, now it will do summation of all these elements. 16 into 4, 64. 64 divided by how many elements are there? So there are 4, so 4, which is nothing but 16. Okay, so this is what our loss function is, that is 16, not this, the square root of this. So 4 will be our loss function. That means that whatever I have got, if I do minus 4 in this, I'll reach my final answer, and that's completely true. Because if I'll do 6 minus 4, I'll reach through 2. 7 minus 3, 7 minus 4, I'll reach to 3. 8 minus 4, I'll reach to 4. 9 minus 4, I'll reach to 5. So that's how you find the minimum square error, and it's completely accurate. Okay, so I'm running this, and if I do loss is equal to MSE, whatever I have got, spreads, and whatever my target is, I do this, and if I do print loss, I can see that I'll get something. I'll get this. Now what's this? Just a minute. If you want to see that by how many points I have missed my answer by using just random values, I have not done any optimization. Import math dot square root, and you can write here your value, and I have missed by 260 points, and that's somewhat true as well, because you know that if I get minus 192 and if you add 260, I'll reach somewhere near 56. Okay, similar to this also, if there is minus 180, not this, okay, because I'll get somewhat wrong answer. So I'm if I get minus 88 and if I add 260, I'll be somewhat nearer to 119. So it's completely wrong, I know that, but still the thing is working. Minimum square error is working. If we iterate it to multiple epochs, we can get the right answer. So here we go ahead. Now we have the loss function with us. So what we are doing is find the derivative of loss function with respect to the input values and the constant that we have. For doing that, we can do loss dot, just a minute. Just now please focus. Okay, this is the part where thing will get a little bit complex. I know it has been till now, but still. Okay, so now we have the derivative of loss with us. So we will find the derivative of our weights. I'll explain you what we are doing. Okay, it may sound a pretty like it's very easy. Trust me, it's very easy. It will fail. Yeah, just a minute. It was it's okay. So now what this is, understand, there's nothing to remember, just understand. Our weights were minus 0.8502. It's random value, completely random. We have nothing to do with this. If our minus 8502 and weights dot grad means it is nothing but derivative of the loss function with respect to WV11. That means the first element. Now what this indicates, this loss function derivative is in negative. That means the slope is in the negative direction. That means if we increase the value, then the loss function will decrease, and if we decrease the value, our loss function will increase. And our major objective is to decrease the loss function. Therefore, we will increase the weight. Rewind the video if you have not understood, but this is very important to understand. Consider this diagram. Okay. Consider that I'll just explain you what this says. These are the weights and this is the loss function. Our task is to minimize the loss function as much as possible. Now, why this shape has been formed? Because if we increase the weights to infinity, our loss function will be, very high because it does not make sense. And similar for minus as well. If our weights are in minus infinity, similarly loss function will increase as well because it's of no sense. Therefore, what we are trying to focus on is, let's consider this point. Okay, this point is basically over this point of minus. Okay, just a minute. Think of this as minus. Okay, think of this as somewhat here, and the line will be same. I'll just take a positive point if there is. Okay, there is a positive point. Let's consider this case, 0.3993. Okay, so this is 0.3993, and the slope is in the negative direction. That means minus 1.3288 is the slope. So now, if we move in the positive direction, the loss function will increase, and we don't want that. If we move in the negative direction, loss function will decrease, and we want that. Okay, so remember that whenever the loss function is positive, we have to decrease the value, and whenever the loss function is positive, we have to. Sorry, I really fucked. I messed up. Okay, so when the loss function, just take this case. There's nothing to remember or something, but if the loss function is positive, we need to decrease the value because then only our loss function will decrease. But if the loss function, or if the the value that we have got here is negative, then we need to increase the value because then our loss function will decrease. Mind slightly confusing, but please bear with me. Okay, I'm trying my best to make you understand. Okay, so there you go. And after we have done the gradient, we need to again reinitialize them to 0. So here's how you reinitialize it. Okay. Just change this to weights and weights, and there you go. This will change back them to 0. So we'll do that. But this is like, we have done the whole iteration. But what have we gained? Have we gained something? So in the loop, when we will be trying to focus, when we will trying to, loop it through, just remember one thing. Whenever you get the gradient part, we will multiply it with a certain coefficient. It will be a very less number. And we will do subtraction with the original number so that it gradually increases, gradually improves. Okay, so let's take back this example. So if we are at here, and if we figure out that our slope is in the positive direction, okay, if the slope is in the positive direction, that means that that when our value will decrease, the loss function will also decrease. So what we can do is, we can do a very small change in the value so that it might not shift from here to here or something. It will definitely change its direction to something where the loss function will also decrease. Okay, so that's what we are trying to do, adjusting the weights. Okay. I'll be currently iterating through 100 epochs. So for I in range of 100, that's this model inputs. So basically this will be generating a random prediction. Okay, for the first iteration, it will generate a random predictions. Loss is equal to minimum square error, threads, targets. This will generate the loss function for all the random values in the first iteration. I'll just print the loss so that you can see in the iteration that whether it's decreasing or not. We'll find the derivative of the loss function. What this will do is that try to change the original weights that we have formed with respect to the gradient that we have generated in the loss function. So this is the new step. Please focus a lot. Minute weights is weights minus weights dot gradient into 1e minus y. Okay, this is the smallest value that I have chosen so that it might not change the original weights drastically, but only a few minor change will be more than enough. Minus is equal to b dot gradient star 1e minus phi. Okay, and I'll again reinitialize the gradients that I have generated to 0. Okay, it's dot grade underscore 0. Similarly, b dot grade dot. Okay. Just a minute, I think I messed up somewhere. Okay. Trying to backward through graph second time, but saved the internet have already been freed. Specify return graph true while calling the back. Okay, I think I've got the problem. What the problem is, it has stored the value of our initial return. So what I want is that just take the value and just a minute. Thing is weights. I'm just keeping them weights and one more time. Okay, it worked. Okay, I really forgot to also, just a minute. I'll do that for you guys. I'll print the loss function so that you can see that what is the error that I got. Okay, so here are the 100 epochs that we generated. Initially, the epoch was 482. That was, as I just told you, that it will decrease as we move on gradually. So it started with 482, and the loss function was continuously decreasing till the point where we actually got it around 156. So now our loss function is minimal. And now if we try to predict our prediction, which initially were in minus, and if we see to it that how much we have got, we can actually see that we have something with us, and that's more valuable. Now if I write predict is equal to model inputs, and I know how much it will be. It will be near to 140 or something. Preds target. Near to 156. That's really nice, because initially it was, when we did it was 6,000 or something. That was now it's only 156, and that too it's square root. We have to do square root of 156, and then we can just a minute. I'll do that also in the. I think we can do that here. It will be somewhat similar to 30 or something. 30, 40. Oh, sorry. It will be somewhat similar to 12 or 13. Yeah, 12, 144. So it will near to 12. I think 12 will be the loss function. And now if we see, now if you see our preds, it will be more closer to our target. So if we write target, okay, targets, sorry for this. Yes. So now you can see that if our target was 56, we got 60. If our target was 70, we got 74. If our target was 119, we got 108. If our target was 119, sorry, if our target was 37, we got 62. That's a bit vast, but it's okay though. For 103, it's 85. So it will be plus or minus 12, but it's more or the other less. It's far more better than what we have received. We can change that. If we do somewhat, let's say if we do 150 epochs and we try to train this again, and if we see the loss function, it will be decreased obviously. it will be okay, it's very less, but now it's overfitting. So you can see now the values are much more closer, but just remember that it might lead to overfitting. So please take that also into mind. So that's it. I hope you have, got some understanding of it, and that's it. Thank you so much.